Factoring special products is what we're going to do today, but I want to make something very clear. If for some reason you don't see the patterns or you struggle to see the patterns in what I'm going to show you today, everything that we are going to do today can be factored in the ways that we have been doing before. You can still use AC method, you can still use box method, you can still factor with the GCF. That will all still work. Just there are cases where you have two types of special products that they show up, and they show up quite a bit, and if you can learn to recognize them, you can factor them very quickly and not have to go through all of that. But like I said, if you don't see the patterns right off and you struggle with them, it's okay, because you can factor in the other ways that we've learned. So the first special product we're going to talk about are called perfect square trinomials. These right here are the standard form of what a perfect square trinomial looks like. It can either look like this one with the a squared plus 2ab plus b squared, or it can be a squared minus 2ab plus b squared. What it cannot be is a squared minus 2ab minus b squared. There cannot be a minus sign here. If there's a minus sign right there, then it's not a perfect square trinomial automatically. This minus is fine, but having a minus in front of this last term is not. But these are standard form. It's what they look like normally. Here are the things that you really need to concern yourself with. First of all, for a trinomial to be a perfect square, the first term, this one, and the last term, this one, have to be perfect squares. If they are not perfect squares, you automatically don't have a perfect square trinomial. The second thing that you have to concern yourself with is this middle term right here. This middle term has to be 2 times a factor from the first term and a factor from the last term. So it's, and I'll show you, but it's, you take a factor from this one, a factor from this one, and then times 2. And that's what makes the middle term work. This is sort of the hardest one to catch because this middle term thing takes some practice. But so we're going to do that. We're going to do a couple so you can start getting used to this. First thing we're going to decide is whether or not what we're dealing with is a perfect square trinomial. If it is, we're going to factor it. If it's not, then we're going to explain why and move on. So here is the first one. The first term is 4x squared. 4x squared is a perfect square because 2 times 2 is 4 and x times x is x squared. So 4x squared is a perfect square. Its two factors are 2x and 2x. You're going to need to know that. Now the last term, 1, is also a perfect square because 1 times 1 gives me 1. So they're both perfect squares. There are my factors. Now to check this middle term right here, I have to take 2 times one term from the first one and one term from the last one. So I'm going to multiply that. 2 times 2x is 4x, and 4x times 1 is still 4x. This is the number that is in the middle. So this is a perfect square trinomial because I have perfect square at the first, perfect square at the end, and the middle term is 2 times a factor from this one and this one. Okay, so here I have a perfect square trinomial. Now I'm going to back up for just a second. It looks like this one, the second one. And because it looks like the second one, then my factors are going to be a minus b times a minus b, or just a minus b squared. Since I have already factored out what the factors are for the a and the b, then it's really very easy, okay? I take a factor from the first one, which is 2x, minus a factor from the second one, which is 1. And since this is a perfect square, I have to write it twice. So it's 2x minus 1 times 2x minus 1, or 2x minus 1 squared. So let's try another one. 81x squared plus 90x plus 25. So let's check it. 81x squared. Well, that's a perfect square because 9 times 9 is 81. X times x is x squared. So 81x squared works. Its factors are 9x and 9x. And then 25, we all should know right off, that's a perfect square. 5 times 5 gives me 25. So far I check out. So let's check the middle term. 2 times a factor from the first one and a factor from the last one. Well, 2 times 9x is 18x, and then 18x times 5, well, that's going to be 90x, unless I, am crazy and didn't do my math correct. And I did. It equals 90x. So the middle term also checks out. So my two factors are, there's one here and one here, and since this one is a plus sign here, my two factors are 9x plus 5 times 9x plus 5, or 9x plus 5 squared. It doesn't matter how you write it. This is just as correct as this. Just know that if, it's a multiple choice test, you will probably see this, not this. But they both are correct. It doesn't matter which one you write. So these were both perfect square trinomials. I have factored them. Let's check the next one. 9x squared. Well, that's a perfect square. Its two factors are 3x and 3x. And then 64 is also a perfect square. Its two factors are 8 and 8. So far we're good. Let's check the middle term. So I have to do 2 times 3x times 8. Well, 2 times 3x is 6x, and 6x times 8 is 48x. This is not the number that is in the middle here. This 48x is not what I see. So this is not a perfect square. And it's not a perfect square because the middle term is not 2 times a and b. And so it's not a perfect square. I'm not going to factor it. If you just have to because you just want to know, you can use AC method. But this one's not a perfect square, and since the direction said, you know, I don't have to factor it, we're not going to. So that's what one looks like that is not a perfect square. All right? Let's do another one. Why don't you take a second and look at this one, x squared plus 5x plus 4, and see if you can determine if it's a perfect square trinomial or not. Pause for just a minute, see if you can figure it out, and then when you come back, we'll see how you did. So x squared is a perfect square. Its two factors are x times x. 4 is also a perfect square. Its two factors are 2 times 2. And if I check the middle term, 2 times x times 2 gives me 2x times 2, which is 4x. Well, 4x is not what I have in the middle, so this is not a perfect square. And again, it's for the same reason as the last one. It's because the middle term does not work out like it's supposed to. It's not 2 times a times b. So pause again and try this one really quick. See if you can check to see if this one is a perfect square. Why don't you just pause the video, try it really quick, and then when you come back, we'll talk about it. So x squared, perfect square, this is x times x. And then 49 is also a perfect square. Its factors are 7 times 7. And so the middle term, 2 times x times 7, well, 2 times x is 2x, times 7 is 14x. Yes, the middle term checks out. This is a perfect square trinomial. So my factors are going to be, because of the minus sign here, they're going to be minuses, x minus 7 times x minus 7, or x minus 7 squared. That's perfect square trinomials. That's the more difficult of the two special products. The next one is actually pretty easy. The next one, oh, sorry, we're going to skip this problem. We'll come back to it. We'll probably do it tomorrow as warm-up. So, the next special product is called difference of two squares. A difference of two squares is really very easy. Okay, this is what it looks like, a squared minus b squared. This is what it looks like when it's factored, a plus b and a minus b. 1 plus, 1 minus is what makes this not have a term in the middle, because this plus and this minus will cancel each other out. Here's the things that you have to keep in mind. What you have to concern yourself is, first of all, the two terms have to be subtracted. It is not a difference if there's not a minus sign. And both terms have to be perfect squares. This is much easier to recognize than a perfect square trinomial. So these are pretty simple. So the first one, we're just going to first of all decide if it is or isn't a perfect difference of two squares. And then if it is, we'll factor it. So this one, well, it's a difference. I've got a minus sign. All good so far. Now, 1 is a perfect square because 1 times, so 1's a perfect square because 1 times 1 gives me 1. And then 4x squared is also a perfect square because it's 2x times 2x. So my two factors come from right here. They are 1 plus 2x and 1 minus 2x. And if you multiply this out, when you get done, the term in the middle is always going to cancel, and so you don't have anything left. The 1 plus 1 minus takes care of that. So, those are my two factors. Difference of two squares is actually very simple. Now, the next one, we're going to have to go back to some multiplying with exponents rules really quick, okay? X to the fourth is a perfect square, and here's why x to the fourth is a perfect square. Because if you will remember, to be a perfect square, all I have to do is a number times itself. Well, to get to x to the fourth, I have to multiply x squared times x squared. Because if you'll remember, when I multiply these, I have to add the exponents. Well, 2 plus 2 is 4. That one was probably easy for you to recognize because y'all know that 4 is a perfect square. But the reason why it's a perfect square here is because I had to add these two exponents. So this one works. Now this one, 25y to the 6th. you're probably going to recognize the 25 right off as a perfect square, but you're not so sure about the y to the 6th. So let's talk about this. 25y to the 6th. Well, you know I've got to have 5 times 5. To get y to the 6th, I have to do y to the 3rd times y to the 3rd, because I have to add those exponents together, and 3 plus 3 is 6. So when you're checking exponents to see if they are perfect squares, it is not something times itself, it is something plus itself, because if you'll remember, when multiplying exponents, you're adding, not multiplying. So this really is a perfect square because it's 5y to the 3rd times 5y to the 3rd. It meets the definition of a number times itself. So yes, this is a perfect square trinomial. And so, I apologize, it's a difference of two squares. So my two factors are going to be x squared plus 5y to the 3rd times x squared minus 5y to the 3rd. So those are my two factors for that one. So look at the next one. 3p squared minus 9p to the 5th. Well, let's check the first one. 3p squared. Is 3 a perfect square? No, 3 is not a perfect square. Therefore, this is not a difference of two squares. It's not a difference of two squares, so I'm not going to have to factor it. You could, if you wanted, you could pull out a greatest common factor and go that route, but you don't have to because it just doesn't meet the criteria for what we're going over today. So that is not a difference of two squares. So the next one. Again, we're going to do this again. We're going to decide if it is a difference of two squares, and if so, we're going to factor it. So pause the video for just a second, test this one, decide if it's a difference of two squares or not, and then come back. So 100x squared is a perfect square because 10 times 10 gives me 100, and x times x gives me x squared. So there are my two factors. 4y squared is also a perfect square because 2 times 2 gives me 4, and then y times y gives me the y squared. So this one is a difference of two squares. The factors are 10x plus 2y and 10x minus 2y. So check the next one. Pause the video for just a second and go ahead and check the next one. Decide if it is a difference of two squares. Remember, when checking exponents, it's a number plus itself, not a number times itself. So p to the 8th is going to be a perfect square because it's p to the 4th times p to the 4th, because 4 plus 4 is 8. And then 49 q to the 6th. Well, 49 is 7 and 7. And then q to the 6th gives me q to the 3rd and q to the 3rd. So this is also a difference of two squares. The two factors are going to be p to the 4th plus 7q to the 3rd and p to the 4th minus 7q to the 3rd. And those are the two factors for that one. So that's difference of two squares. And then the other one was perfect square trinomial. So let's practice just a couple more just to make sure we're getting it. There's 3 on here. I'm only going to do 2 of them just to make sure that we understand. So take this one, pause for a second, and see if you can test this one to see if it's a perfect square trinomial and factor it. And then when you come back, you can see if you got it right or not. 121x squared is going to be a perfect square. Because 11 times 11 is 121, and x times x gives me x squared. So that one's a perfect square. 4 is also a perfect square. It's 2 times 2. So to check my middle term, I have 2 times 11x times 2. Well, 2 times 11x is 22x times 2 is 44x. My middle term checks out. So my two factors are 11x minus 2 because of that minus sign right there, and 11x minus 2, which is the same thing as 11x minus 2 squared. So that one is a perfect square trinomial. So test this one. Use what we just did. Pause for a second. Decide if this is going to be a difference of two squares. 9x squared is going to be a perfect square because its factors are 3x and 3x. 144y to the 4th is also a perfect square because its factors are 12y squared and 12y squared. And so then when you factor, you come up with 3x plus 12y squared and 3x minus 12y squared. And so those are your special products. I hope you enjoyed practicing. I will see you guys tomorrow.